Hey guys, welcome back to Talk Time with Tandem. I'm Max, I'm one of the founding engineers here. Today we want to do more of a financial economic talk about AI, just kind of guide through the main models, the pricing, the options that you have, and just talk about what the availability of the market is in terms of economics of actually running these models. So I'm sure everybody here is familiar with AI models, how to use them, just as a high-level overview. You have two types of models. So you have frontier closed-weight models. These are the OpenAIs of the world, the Anthropics. They give you access to these models, but you actually cannot download the weights and run them locally yourselves. Then the other side of the market is open source models. These are models that are available to download. You could pull the weights and then you could run them in your own environment on hardware that you either own or rent out. There are two ways of accessing these models. The easiest way that you could go about this is to use an open source API. So you could go through a router, such as OpenRouter. You could go through one of the many open source API providers, such as Fireworks Together, or you could self-host on either VPC or cloud or some on-prem hardware. So let's just run through the main models, the pricing, and see how these compare. So for the frontier models, for Claude and GPT, this breakdown is going to be on the number of engineers at a company using and accessing these models. These are scoped to the number of engineers, but you could also think of one engineer as running some sort of task. So, the jump from 1,000 to 5,000 engineers doesn't necessarily have to be 4,000 more engineers. It could be, one engineer running many sub-agents. It could be some online chatbot within the enterprise. We're just thinking about this as the number of requests that are pinging a model. So we're going to range from 500, 1,000, and 5,000 people. Between Claude and GPT, GPT is actually slightly more expensive for their frontier model. It's $5 per million input tokens and $30 per million output tokens. Opus from Anthropic is a bit cheaper, input the same, $5 per million, but output is actually $25 per million. And for Claude, if you have a team of 500 engineers per month, this is going to cost you $470,000. GPT is going to cost you $490,000, so GPT a little bit more expensive. For 1,000, it's going to be $930 for Claude, $975 for GPT. And then for 5,000 engineers, again, this is a huge enterprise, but could also be not necessarily a jump of 4,000 more people. It could be a few more engineers spawning up 100 sub-agents, recursive tasks, longer context windows. This jumps to $4.7 million and almost $5 million per month for a company using a frontier model. Okay, so let's say you're a company and these prices are exorbitant. They're too much. So you say, you know what? I see that everyday open source models are closing the gap. They're catching up in the market. So I want to try an open source alternative, a frontier open source model, such as DeepSeek v4 Pro or GLM 5.2. But I don't really have the engineering capacity to go and host these models on my own infrastructure. The engineering overhead is too much. So what I'm going to do is I'm going to use some sort of API provider for these models. We aggregated the pricing based on the cost per million tokens between all the providers, but it's for DeepSeek roughly 143, 290, and 1.4 million. As you can see, the cost is drastically cheaper between the frontier equivalent. For GLM, it's about the same at 120, 240, 1.2. Now, let's go over to the self-hosting alternative. If you look at these two columns between DeepSeek and GLM in a self-hosted capacity, you might be thinking to yourself, holy shit, this is way more expensive. Why wouldn't a company just opt in to use a frontier equivalent or an API equivalent? Well, the issue is that some companies are forced to operate in these two columns. Think of the last time that you went to ChatGPT and pumped your social security or tax information through it. You probably wouldn't do that for reasons of privacy. Think about all the institutions that deal with financial data, legal data, all the pharmaceutical companies that have proprietary knowledge. They can't afford to give their data to a third-party provider, so they're forced to operate within a restricted space using their own hardware. But this is really expensive because compute is really expensive. We model this assuming that you use H100 GPUs from NVIDIA. You need 8 H100s is a single node, and that costs you about $5,000 per month. But these models are so big, and we're making some assumptions, so we're assuming 20% concurrency, 30 tokens per second, and a million context window, which is the one that's really biting us here in terms of price. So you actually need a large number of nodes and a large number of GPUs to even distribute these models in the first place. And that's why the pricing goes up so much. For a team of 500 engineers, you're paying almost $1 million a month to run these models. That's almost $12 million a year. And that jumps almost 9 times when you scale your enterprise. This is why we exist as a company. If you're forced to operate in these 2 columns, the focus doesn't only end with how do we even integrate AI into our products. It's, okay, we're forced to self-host, but what are the true optimization strategies that we can use to maybe not pay $8 million a month to even deploy a single model? There's so much research coming out in the way you actually distribute these workloads. LM Cache talks so much about caching. You could route requests. Even the parallelization strategies of how you distribute these models on the hardware that you have can dramatically lower the cost of this. Now, a lot of companies don't do this off the gun because the engineering that goes into it is extremely difficult. Teams that don't have the luxury of a huge MLOps team don't have the luxury to sit and decide how to even distribute these models in the first place. The emphasis goes on just getting them up and running. But by utilizing multi-cloud, by utilizing heterogeneous hardware, so maybe you don't have 10 nodes of purely H100s. Maybe you utilize your on-prem capacity. Maybe you combine different hardware from AMD. Maybe you use some cheaper GPUs from NVIDIA. Combine them into a single cluster and try to connect them in a way that you're actually not using the most expensive hardware for every single task. There's a lot of optimizations that could be done in these 2 columns that can drive down the cost and get them closer to what these 2 are. Now, you might be asking, how do API providers have the luxury of having such cheap prices? Aren't they doing the same thing that you would be doing as an enterprise, deploying these models? One is they have the luxury of demand. They have so many requests that they can batch them together and utilize the resources in a much greater way. 2, we also have to remember that these people are actively burning money, right? They're making a bet on the future that they're going to build out the infrastructure, and by the time they get there, the demand will be there so they can actually become profitable. But for every dollar that you're spending, they're actually losing money on that. They're backed by a lot of VCs that allows them to basically have your business. So the worst thing you could do is, if you're in these self-hosted environments, is naively deploy and turn a blind eye on all the optimization strategies that you can do. As I mentioned, LM Cache is a great example, but there are so many open source alternatives that help you scale within the limited capacity that you have, such as NVIDIA Dynamo, you have Raise Serve. There's a lot of things that you could do today that will help you reduce these costs, because the prices that we listed here are very naive vanilla deployments that just focus on getting these models up and running. So I hope this was a relatively good overview on the pricing, and it gives you a better picture of really what it means to even run these models and use them in the first place. Thank you.